Hello there. So in this video, I am going to go over the flight control and hydraulic system on the MD-82. So as you can see here, I have this entire uh, manual here, which goes over everything on the aircraft systems. So initially, before I refer to that, I'm going to show you some of the things that I already know that we're going to go ahead and go over, and I'm also going to go over some of the things I'm a little confused about that I don't understand and require more research. So one of the things we're going to go over, the most important one, is the overall flight controls. So the MD-80 has two ailerons on the left and right of the wings, which control the roll. And we'll go ahead and show those really quick. One of them is this entire piece right here. The other aileron, obviously same side, right here. It also has a inboard and outboard flap on either wing. Inboard, outboard. There we go. Along with this, you have a rudder back here to yaw the aircraft. And right here, you have the elevator, and then the piece the elevator is connected to right here, the stabilizer, the horizontal stabilizer. So the first thing we're going to go over is the MD-80, for most of its flight controls, does not use hydraulic power in order to operate them. Except the elevator, but it's only for when the aircraft is in a stall condition. So if the aircraft is at a high attitude and the nose is pitched up really high, in order to give the aircraft just the amount of push it needs to push the nose down, the entire elevator piece here pushes down in order to get the nose down. But under normal operations, when the pilot is using the control column, the elevator is not connected to the control column, and I'll explain that in a second. That is because it uses control tabs in order to move the elevator and the ailerons in order to then enact a force on the aircraft, causing it to move. So you can see this little tab right here is one of the main control tabs. This control tab uh, is what angles up and down, and it creates an aerodynamic force, which then moves the elevator piece, this piece right here, up and down, and then that creates the force which moves the nose of the aircraft up and down. It has a second tab here, which does the same thing, and farther out, it has what's called an anti-float tab. I'll go over what that does after I just go over what all these do. Well, sorry, not what they do, just their names and where they are. The aileron here, sorry, has a trim tab and also a control tab on it as well. It works just like the elevator, how the control tab moves. The displacement of the airflow that the control tab creates forces the aileron either up or down. The trim tab is just to change the flying position of the aileron in order to make the aircraft be trimmed left or right. The rudder right here, as you can see, only has a control tab. The trim moves the control tab, and then the control tab is what's connected to the pilot's control column, so you can move the rudder. All right, now that that's over, let's go on which each one of these do. So we already went over the first one. This tab is what moves the aileron up or down, or sorry, the elevator up or down, which then creates the lifting force, which moves the nose up or down. The second tab does the same thing, but it is boosted in order to increase the amount of control the pilot has. In fact, let's go ahead and refer the manual here, flight controls. Let me see if I can find it here. I gotta remember what page it is on. I'm pretty sure it's right. All right, so we have a geared tab. So if we can find that really quick. Directional control is provided by the rudder, moved by blah, 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 longitudinal, horizontal. A movable horizontal stabilizer for its longitudinal trim. So I'm looking for... Okay. Control system operates a single tab on each elevator. Movements of the control column move the control tab, and aerodynamic force in the control tab moves the elevator. As each elevator moves, an additional tab moves to assist the control tab, so it's geared. So basically, if I can open Microsoft Flight Simulator here, this second tab is geared to the tab on the right. So when you move the tab on the right, then the one on the left also moves in order to increase the amount of force that's applied, and that moves the elevator up. The last one, this is the one I do know what it is. Sorry, it's a lot of information, so sometimes I'm forgetting some of this stuff. This tab right here is a anti-float tab. Now, the anti-float tab is geared to the position of the horizontal stabilizer here. So the horizontal stabilizer, which is this big piece, rotates down and up in order to trim the airplane, so to allow the nose to fly up or fly down, basically. That way the pilot doesn't have to do continuous back pressure, continuous forward pressure to fly the aircraft level. One of the problems, though, is that when the horizontal stabilizer is moved, the elevator is not going to want to fly with it. And what I mean by that is that if the stabilizer is pointed down, the elevator is going to fly level with the oncoming airflow. So it won't fly on the angle that the stabilizer's at. And you don't want that. So what you do is that this other tab right here, the anti-float tab, is geared to the position of the stabilizer. So when the stabilizer angles, this tab moves to then make the elevator fly level with the stabilizer. And that's the purpose of the anti-float tab. You need this to happen because if this trims and this is flying level with the air, it can nose down, it'll basically nose down the aircraft and the pilot will not have adequate control of the airplane. So that is what all those tabs do. So we've gone over the tabs, what the elevator does, and what the horizontal stabilizer does. Next, we'll go on to the rudder. So as we talked about, these are not hydraulically operated. I said they were directly connected to the control column. So there's no hydraulic assistance done here except for the assistance that kicks on in a stall condition. So the elevator has a hydraulic connection in the event of a stall to force the nose down. But other than that, the rudder is the only flight control that is hydraulically powered. So you can see there are two pieces to the rudder here. There's the main large piece and there's the secondary tab. So the large piece, when hydraulics are on, is operated hydraulically. So when the pilot moves the rudder pedals to make a movement to yaw the airplane left or right, the hydraulic boost will push the rudder because it's really hard to move. It's a really big control surface and at speed the pilot really doesn't have enough force, or it may just be really hard to move with that speed. And so it's hydraulically boosted, so that way the pilot doesn't have to do all the pressure to move it. However, if there are no hydraulics, the pilot inside the cockpit here can turn on a switch. It is this, there's a yellow, I might not be able to look at it perfectly. Anyway, behind the speed brake lever here, there's a little yellow switch you can move back. And what that does is it cuts off the hydraulic system to the rudder and then puts all the control mechanically to this little tab. And just like we talked about with the elevator and aileron, this little control tab will move, and then the control tab, then essentially the aerodynamic force on the control tab forces the rudder to move left or right, and then the rudder, the force that the rudder creates, yaws the aircraft left or right. Okay, so essentially, the rudder is the only hydraulically powered control surface. I know that the elevator is too, but it's only in the event of a stall condition. So for the purposes of this, the rudder really is the only hydraulically controlled surface. Then we're going to go on to the flaps. So the flaps here, there are an inboard and outboard, and they're technically what are called double slotted flaps. So you have these big pieces, and then on the inside you have this other tiny little wing right on the front of it, okay? So the flaps here fold out and down to increase the length of the wing, which increases the amount of lift. And not only do they increase the length, which increases the amount of lift, it also increases the amount of air trapped under the wing, which also creates a lifting force up. So that's the purpose of the flaps. It allows you to fly at lower speeds at the cost of having more drag. And that's why they come out for landing, so you can slow down. And each of these flaps are controlled by a different hydraulic system. So there's two hydraulic systems, essentially. There's engine 1 hydraulic system, or system A, and system B. and we'll just call it System A or System B for the purposes of this. And if I go to the cockpit view really quick, just give me a second here. You can see we have the hydraulic switches down here. You have the left hydraulic system and right hydraulic system. Left one is controlled by the left engine, right one's controlled by the right engine. The aux pump here is an electrically powered hydraulic pump, which then can supply pressure to, and if I remember correctly, I think it's to the right hydraulic system. If I go out of the flight control page and we go to hydraulic power, let's find it here. It should be here somewhere. All right. Auxiliary transfer pump. Transfer pump. Is there an aux pump? Okay, so the aux pump can apply pressure to both the left and right system, granted that the transition pump is on, and the transition pump is technically connected to the left system. So when you turn it on, it will take the pressure from that side and can move it over to the right, etc. And then the aux pump can then move it to the left. Anyway, so as you can see here, the left hydraulic system is responsible for the inboard flight spoilers on both wing. And so what that means is that these spoilers right here, the inboard, which is this small tab right here, is this little white tab, is controlled by the left engine hydraulic system. And this inboard tab is also controlled by the left engine hydraulic system. And the outboard tabs are controlled by the right engine. And the flaps are also similar. Outboard flaps are done, which is this big flap, is done by the left engine, and inboard flaps is done by the right engine. And then the rudder power is controlled by the right hydraulic system. The slat mechanism is done by both hydraulic systems. The air stair, which is a stair that comes down the tail to board passengers, is hydraulically controlled by the right hydraulic system. Nose wheel actuator is done by the right hydraulic system, etc. So we just went over the main hydraulic system for the aircraft and flight controls. That is pretty much it. The only thing I think I'm going to go over is the conditions at which these come out, because it's important. So the flaps obviously can be controlled at different positions, and you have several positions here. You have the up position, which means no flaps. You have 0, 11, 15, 28, and 40, okay? So when you set it to 0, the slats, in fact, let's power up the airplane just so I can demonstrate this really quick. If I go here, ready for takeoff, change the state of the airplane. All right. So now what you'll notice is that if we set the flaps, let's go to up. All the way up. Come on. It's not wanting to go up. Awesome. So anyway, as you can see, flaps 0 brings down the slats to full. And if we go down to flaps 11, as you can see, the slats are still all the way down, and you can see the rear flaps are coming down. All right? And then if we go flaps 15, the slats then go down to their full length. Okay? So initially, let's see if I can get it. I don't know why it doesn't want to go back to the up position. It's doing something funky here. Here, let me plug in my throttle quadrant here so I can see if I can get that little glitch to fix itself. Customize, go back. Oh, whoops, turn that off. Go ahead and press. Okay, so as you can see here, now there we go. Now I can go to the up position. Let me do something really quick because the aircraft decided that it wanted to roll forward. No, I don't want you. Let me go ahead and hit Shift P. There we go. Yeah, sorry, I didn't have the parking brake on there when I decided to do that little test, and the engines were throttled up, so it moved us. Push it back just a bit more here. All right, we can go ahead and stop the pushback, parking brake, and it doesn't want to activate. Brilliant. Okay, there we go. Now it does. Anyway, so when we're in the fully up position, not even slats are out. When we go to the 0 position, slats move down to their halfway position. Or sorry, yeah, there you go. See? Halfway position. When we go to flaps 11, the rear flaps come down. And when we go to flaps 15, the rear flaps go to then the 15 position, and the slats go down to full down. Then we go to 28. The rear flaps move to 28 degrees. And then if we go to 40, they will go to 40 degrees flaps. Also, just to show you, as you can see the control tabs here moving on the elevator there. Yep. And then we can show you the rudder, which is hydraulically operated. So you can see right now that little tab isn't moving, but if we were to use the rudder trim, it would move, or in the condition, if there was no hydraulic power to it, it would simply move the little tab here, which would then move the entire rudder. But obviously, we want hydraulic power, so, okay. So as you can see, also the slats will change their position relative to the speed of the aircraft as well. So, for example, if I started going above a certain speed, I would have to bring the slats up. And if I go ahead and go to flight controls, yep, here we go. The slat system, high lift device located on the leading edge of the wings. Normally the slats are operated by both hydraulic systems, but will continue to operate at a reduced rate with a single hydraulic system. The slats are manually actuated by the flap slat lever. 3 slat positions may be selected: retracted, mid-sealed, extended. The slats are retracted when are up, mid-sealed when flaps are 0 to 13, and extended when flaps are 15 to 40 range. So there you go. That's everything about that. So other than that, that's the main overview of the flight control system on the MD-82. And I'm going to go ahead and conclude, because this is going to be the last video I do for my senior project. Because the whole purpose of my senior project was just to learn how to operate the airplane's systems. I did, however, spend my own time learning how to fly the aircraft itself, but that was not the purpose of the project. The purpose of the project was just to learn and get a deep understanding of the aircraft systems. So I went over all the main ones, that way I didn't have 25 different videos, because this has taken me a lot of time. It's taken me hours and hours and hours and days and days and days to get all this information and to learn it on, to commit it to memory, etc. And then I've also had to play with all the systems to see and to, operate them the way that the manual tells me to. So this has taken me a really long time, so I just decided to condense all the major points into 3 videos, so such as the pre-flight of the cockpit, starting the engines, and going over how the flight control system works, the 3 major things to getting the airplane into the air. So other than that, I'm going to conclude the video now, and I thank you for joining me and listening, and have a good one.